Just a brief introduction about Bloomberg. I guess if you're not in the finance industry or live in New York, I don't know if you've heard about Bloomberg. But essentially, the business of Bloomberg is there's four parts: the professional service, which is a terminal. I'll describe a little bit later. It's the main, the core service that we provide. Media, Bloomberg TV, various like newspaper as well. Industry solution and enterprise. For example, recently we've developed new indices for the financial market. So that's industry solutions. This is the main product, and this is where we are actually now using OCaml. It's the Bloomberg Terminal. Essentially, it gives about 300,000 users around the world access to financial data, news, analytics, big calculators that allow to crunch a lot of numbers and gives interesting results. Essentially, it enables everybody in the finance industry to make key decisions. Okay, so Bloomberg is a technology company. We are 2,000 developers. There's a subgroup called Derivatives, which I'm part of, and there is a team called the Derivative Library, which is about 20 developers. So this is where we're actually using OCaml. It's a start. So the programming language at Bloomberg, essentially, it's very broad, right? If you find a programming language that you think will do the job, then it's the right one to use. But the most used languages is C++ and C. We have lots of very good and expert people in C++ and C, and a lot of the backend code is written in this language. Front-end UI code is written in JavaScript, so very common. And OCaml. So my team is actually actively using OCaml, and I'm going to tell you the story about that. So actually, just to give you a little bit more insight on the team. So even though there are 20 developers, there's about 6 people that are actively developing in OCaml, and we only have one person that we hired specifically for OCaml. The rest of us are people that have never touched OCaml before, never touched functional programming before. We also have people that have never done computer science, right? They're coming from chemistry background. They have a very broad background, and we just hire them because they're bright people. And it's incredible how fast one can learn functional programming. I mean, just to give you a little story, one of the developers in my team, she joined a year ago. She joined Bloomberg after a PhD. We have a training program at Bloomberg, 4 months. She learned C++, and 2 months after that, she was programming in OCaml. So if you imagine how fast someone can go from not learning C and knowing C, C++, and then OCaml, it's incredible. Okay, so what are the kind of problems we are solving? Essentially, in the finance industry, you have 2 people that are going to make a deal between themselves, a derivative contract, and they're going to agree to exchange a certain amount of money, and they're going to have rights and obligations. Okay, so one of the challenges is how do you capture this information, and then how do you provide tools around this contract? And we have basically 2 types of analysis. We have deterministic analysis. We look at what the contract means, and we try to provide explanation. But we also have what we call stochastic analysis, where we leverage the entire set of market data that we have available at Bloomberg, and we use quantitative models to actually give a fair value. So here, Bloomberg kind of like sits in between those 2 guys. We're independent, and we're providing tools for either of the counterparty to kind of understand and have a better idea of what they're trading. Okay, where OCaml started, it has to start somewhere. It all started 2 years ago, and with a partnership with CUFP, which is also heavy users of OCaml. And the story is that really, I mean, we have incredible business people at Bloomberg, and they're the one that push for it. And we're like, okay, they're using OCaml. It sounds, very interesting. We're not afraid of functional programming, and this is how it all started. And then just to relate to Joe talk earlier, this is where having the umbrella really matters. So when you have your business people that really supports the technology, that really understand it, that really see the benefit, and they let you work on this for 2 years without massive pressures, and they're very supportive, it helps a lot. And all of the other points that he mentioned as well about introducing new technology in a large company is also true. We are a team, we're not an individual, and we have a dedicated product that we're developing, and we have the umbrella, nice boss and nice business that supports us. So here is the challenge a little bit in the capturing contract. What you have is like, people are going to trade a lot the same contract. However, they have a lot of imagination. And so they're going to do all of those crazy contracts between themselves. And what you as an independent software company trying to provide information, you have to catch up, right? And so the time to market is crucial. And also the problem is it never ends. Like, even though there's a lot of similar contracts, at the end of the curve, there's always new ones. Every day you're kind of like chasing after the trader imagination, right? You have to keep track of it. So time to market, extremely crucial. Okay, so you start, of course, with the right side of the curve, right? And so for this, you leverage the C++. And what happens is that usually you have a classic C++ representation, and you have a hierarchy, and all good. And then you also have a UI abstraction, right? And then you have, of course, a proprietary UI, in this case, the Bloomberg framework. So very classic, and you can do very hard-coded mapping between all of those representations, right? It's very good, because what happens is, like, if you want to do very dedicated UI, very dedicated roles, it's all possible, right? It's all code that you write manually, so no problem. However, that doesn't scale very well when you have tons of contract out there. So what we did before introducing OCaml was we're like, okay, we're going to start with a single representation of the contract, and we're going to use a fairly neutral representation, XSD. And then we're going to use code generation techniques to kind of like generate the different representation and the different mapping between them. And for this, we use Ruby, a little bit in a functional way, but not that much. And okay, so that worked well, actually. And the only problem is that you have here full technology, right? You have the XSD, you have C++, you have the you have Ruby, and then you have the proprietary UI representation. This is like 4 moving parts in the system, and we don't like too many moving parts. Right? It's hard to maintain, it's harder to understand. So then, thanks to CUFP, we managed to have only one representation driving everything. Using runtime type information from the modify OCaml compiler, we're able to get a UI representation and to do a one-time mapping to our proprietary UI. And this is great because everything is in one language. It's a very easy to maintain system. It's very automated, and it reduces our time to market greatly. But this was the beginning of the story. You kind of make a partnership, you introduce a new technology, you introduce it in your code base, you're happy, but then, you know, we want to take it further, right? We fall in love with OCaml, and all the developers, even though they never knew OCaml before, are not, all we want to do is like program in OCaml. So we're starting to use it for many other purposes. The first one is we created a DSL for financial contracts, right? So we use the classic OCaml legs, OCaml app can develop a mini domain-specific language dedicated that we actually expose to our users, right? And it is a functional language. Not type-safe, but it is functional. We also now do a lot more applications that, you know, like trying to do more introspection about financial contract and give a better idea of what they are and the risk involved. And for all of this, we're using OCaml as well. And document generation, we're also leveraging OCaml quite a lot. So the lesson learned. Well, the classic, like Joe mentioned, increasing productivity. One important thing, like when you go from C++ to OCaml, is how fast it compiles. And this is something that, you know, often people forget. But, you know, you're very productive if you can get a very fast, quick feedback loop, right? And this is, you know, we are constantly trying to improve how fast we can compile, whether it's actually C++ or OCaml, just because it makes us a lot more productive. Right? Of course, the compiler does a lot more work. Once you get past the errors, you know, that's once you understand the errors, everything's fine. It's fun. So this is like the previous talk was mentioning. It is actually really nice for developers to suddenly use OCaml rather than C++, right? It is new, it is fun, and a fun team makes better product. And also, what is like incredible is people have started using OCaml, and they start, you know, doing fold left and fold right and those kind of things, and suddenly the way they write JavaScript is different. They write better code in JavaScript and in C++. So it's really nice. The code quality, this is more internal, right? Like the fact that we have two languages, we now explicitly use them for what they're good at. So it makes the architecture a lot cleaner as well. Okay, so this is more the difficulty part. So we're not a greenfield, so we are integrating a lot with all the technologies that Bloomberg have developed over the years. And one of the things that you do and that you don't want to do is actually mapping types from one, you know, language to another, right? And here, we spend quite a fair amount of time now investing in automatic ways to do this. And the type reflection is a crucial benefit for that. What we, you know, we often talk about the platform and like the how many libraries are out there for a language. Actually, for us, it didn't really matter. What matters is like how quickly can you integrate an existing technology inside the language. And for that, OCaml was very good. The speed was extremely important. OCaml is not supported on all the target architectures that we have. So what we do is essentially wrap this in stateless services. It's great for like scalability, no problem. However, you know, to call an OCaml function, you have to make a network call, and that could be costly. So if you have a fast language, then it's better. Okay, so learning functional programming. I can say that good coding. Some of the things that maybe we would like to see more, maybe because it's the beginning as well, is like more best practice in functional programming. There's a lot of like you know, documentation to actually look at all the possible features of the language. But really, like sometimes we want to find a nice way of solving certain problems, and it's getting a lot better. I have to say, like the book that you know, Real World OCaml is now. We have like several copies floating around in the office, and people are really enjoying this. All the OCaml planets and the blogs and like this is great. Like we're all following it, and it's also a fun way to learn OCaml. And yeah, that's it. Thank you very much.
Questions? So I was very interested to see that you wrote your own DSL, not an embedded DSL, for expressing financial contracts.
Yes.
When sort of part of what LexIFP provides to you is exactly a DSL for expressing financial contracts.
Yeah.
So, and my own experience with sort of at Jane Street dealing with DSLs is that having a decent host language like OCaml makes building real DSLs kind of on the whole less appealing, because every time you write your own programming language, you have your own not very well thought out syntax, and you avoided your own not very good type systems. That was good. Your own not very good error messages, your own not very good tooling. And so I'm wondering, like, in compensation for like giving up all the nice things you get from OCaml, what was the value you had in building this DSL?
No, that's good. Actually, we are not users of that DSL. It's our clients that are users of that DSL. That's the main thing. We internally, when we write financial contracts, we use, of course, OCaml. But exposing OCaml to traders, for example, or to structurers, is we didn't feel was like the best way, and we provided it's very thin layer, like on top of the algebra, but it gives a lot of like quick ways and. Based on our experience about reusable components that you can, we have a library as well that people can essentially in 29 create contracts very easily, and this is where as well we learned that it's okay to have a functional programming programming language to give to users. They actually do it perfectly fine, but yeah, we felt that there was some simplification needed. That's why we added the DSL on top of it.
And you felt like you couldn't get the simplification by defining simpler constructs inside the language and then saying, you write this, we won't tell you it's OCaml. This is the rough syntax, go write that.
Well, that's true. The other one is as well the compiling on the fly, because this is all running in production live, right? So having live compilation, brings like challenging.
Talk to me later about OCaml plugin.
Okay.
Sorry, just when you said users, then you mean users on board?
Can you use my
Yes.
Actually typing the contract definitions in?
Yes, they are writing fold left and fold rights. Not in OCaml, but in this small DSL.
When you talked, you said that you have some architecture that is not supported by OCaml compiler. I wonder what is the architecture and whether you consider to supporting it yourself or pushing patches to support it upstream.
Yes, so the two architecture are Sun and AIX. So it's supported on Sun, not on AIX. We actually made the bytecode run on AIX, but not the native code. Right. So this is exactly something that we are right now thinking. So our goal is to write more and more code in OCaml, right? And that includes migrating functionality that we want to port to OCaml. So here's the debate that we haven't solved yet. It's like, is it okay to kind of make a remote call even for potentially very small functionality, or should we spend the extra effort supporting AIX and to make an in-process call to the library?
And AIX, I just have vague understanding. It's an operating system, but what is actual
PowerPC.
PowerPC. I think PowerPC was supported for some time, so if
Yes.
you express interest and try to support it yourself, it will be easier. Maybe.
Yes. Yeah.
Okay, and also you had the slide where it said that you have 200 developers in research and development, and I wonder whether everybody uses OCaml or you have smaller group.
No, so there's 2,000 developers at Bloomberg, but we're a small group. We're specifically for that product, the derivative library, and actively working on OCaml are about 6 developers. The team itself is doing all the things as well, and so overall we're 20. And I believe that by the end of next year, those 20 developers will be writing OCaml code at least, a day a week. Right?
Okay, thanks.
Thank you.
We'll resume in about 20 minutes with a session on distributed systems.